Class today we're going to go over our new topic, and it's actually a topic that actually fits well for one of these lessons. Okay, it's all about normal distribution. The first things first, this is going to be in OneNote, your content library OneNote under class note, and I'm going to post the video, the link to the YouTube video right here. Okay, so you see at the very top where it says class video. So if you want to go back, or if I go too quick. Hopefully, I guess Ava's closest, so we'll give her the mouse and she can stop and start the video as needed. Okay, so normal distribution. If we remember, normal distribution curve looks like this. Okay, and we've seen the normal distribution curve before. We've looked at distributions that are skewed and whatnot. So the mean, median, and mode on a normal distribution will all land right in the middle. Okay, so the mean, median, mode will all land directly in the middle there, and it's shaped like a bell. Okay, so we've seen this before, but what we haven't seen are these numbers here. Okay, the 1, 2, and 3 this way, and -1, -2, -3. Okay, what those numbers are a standard deviation. Okay, so standard deviation, this would be +1 standard deviation, +2 standard deviation, +3 standard deviation from the mean, or -1, -2, and -3 standard deviations from the mean. And we'll keep going through and learning what that is, so don't be too worried right now. So we know standard deviation looks like the mean lands right in the middle, and now we have numbers that go along with our curve. So the first thing we need to learn is the normal distribution notation. Okay, so you'll see this written sometimes, information about a normal distribution. It'll look like this. It'll look something like this. Okay, and the way it reads is the random variable x, so whatever number we're going to be looking for, is normally distributed with a mean of x and a variance of the standard deviation squared. So that sign there means standard deviation. Okay, let me add it in a bracket here. Oh, shoot. All right, so remember this symbol here means the mean. Let me highlight that. That means the mean, the x with the bar over it, right? And this symbol here means standard deviation. We should write this on your notes itself. I'll show you later. I'll show you tomorrow where to write it. But let's make sure we write this down right now in our notes. So we can tell Ava to pause the video. And I want you to write this down in your notes. Now, what do we need to know from this? You need to be able to identify the mean. So if you see something written in notation, you need to be able to identify the mean and identify the standard deviation when given notation. And later we'll be able to create, and the second thing, we'll be able to create notation given the mean and standard deviation. So just remember where these two numbers are. The mean is the first number involved here, and the standard deviation is the second number. And the standard deviation is not squared. So if that was a 3, our standard deviation is not 9, it is just the 3. So, practice question here. Given this here, okay, x is normally distributed, 10, 3 squared, what is the mean and what is the standard deviation? So I'll give everyone a second to attempt it. At any time in this video, you can pause, or if I have a tendency to go too quick, you can go back. You can ask the slide back. So the mean here, remember it's the first number, so the mean is 10. And the standard deviation in this case is the second number, which is 3. Oops. Perfect. So let's try another one. Given x is normally distributed, a 100, 10. What's our mean and what's our standard deviation? I'll give you 10 seconds. So once again, our mean here is 10, 100. And our standard deviation is 10. Boom, boom. Okay. So we have to commit that to memory. So if we see that, we know what's going on. First number, mean, second number, standard deviation. Now, what if I gave you the mean and standard deviation? Could you write the notation of that? So here's two questions here. So in the first one, your data has a mean of 5 and a standard deviation of 0.5. Write the standard deviation notation. And the second one is your data has a mean of 33 and a standard deviation of 4. Write that standard deviation notation. All right, pause the video here. I gotta go grab this. Pause the video and give it a try, and then we'll have the answer. All right, answer time. So for this one, my mean is 5, and my standard deviation is 0.5. Well, this one is, I have a mean of 33, and a standard deviation of 4. Now, I could be mean one time, not this mean, but a different mean. I write the standard deviation first, and then the mean, and make sure you know how to space that out. That'd be a wonderful test question, actually. So that's standard deviation, not standard deviation. That's normal distribution notation, and how to find the mean and standard deviation out of it. So that's the first part of the lesson. And the two things you need to know is you need to be able to identify the mean and standard deviation within the notation, or be able to create notation when you're given the mean and standard deviation. And I will tell you where to write that tomorrow when we get to our notes of self. So I honestly think we erased it. So this part here is probably, I know some people are writing this down. Don't write this down right now. I'm going to give you, well, I guess Ava's going to give you time, or someone's going to give you time. Here's the most important part almost of the course. Understanding this bell curve. Okay? So let's write it down first. You guys want to write it down. You can write down your notebook, but as well, I want this to go into right here in your notes of self. Normal distribution with standard deviation and percents. So on this, you can write, I have a minus standard deviation here. You can write -1 here if you want. You don't need the standard deviation sign if you don't want it. You can just go -1, -1, -2. Let's just do this. There. So get this written down, and then I will go over it. So pause the video here and get that in your book. and have it somewhere, put it on your notes of self so you can refer to it all the time. Okay, you should be back from your pause now. So, let's do this first. Let me give you, let's grab one of these. Let's grab a simple one. Let's grab this. So let's say I have this information. I have a mean of 33 and a standard deviation of 4. So the mean goes in the middle, right here. And 33 would go in the middle. All right. Now I'm going to go up 1 standard deviation. So up 1 standard deviation would be 33 plus 1 standard deviation plus 4, which would equal 37. So 37 goes there. And then they go up another one. We go 37 plus 4, which equals 41. 41 goes right here. Then lastly, oops, a lot of boxes going on here. This would be 44. This may sound really not childish, really basic, but fill in these numbers every time we get one of these questions that are coming up. Now, we went plus on this side. So it was plus 1 standard deviation, plus 2 standard deviation, plus 3 standard deviation. Now, we're on minus side. So this would be 33 minus 4, which equals 29. So 29 is going to go here. And then, just like we added, we're going to go 29 minus 4, which equals 25. And 25 is going to go above the minus 2. Oops. And then we're going to go one more. 25 minus 4, which equals 21. And that's going to go in the minus 3 section. Oops. 21. So those are the numbers that line up. So hypothetically, this lines up with -3, -2, -1. 33 is right in the middle because that's my mean. 37, 41, and 44. Right? So why is this important? Well, let's say this is marks on a test. Let's say we had this information. This is a normal distribution of a 45 mark test. Okay? And as in 45 marks is in 45 questions. So if we were looking here, the mean or the average on the test was 33. Now, now that doesn't mean anything. What's 1 standard deviation point? What's 2 standard deviation points? What's 3 standard deviation point? Doesn't really mean anything to us. Okay, but in a normal distribution, 68% of the 68, so 34% and 34%, so 68% of the population land between the first 2 standard deviation points. So in here, 68% of the population. So if I have 100 students, 68 would have landed in that section. Okay. Then when you get 2 standard deviation points out, it's 34, 34 on this side, and it's 13.5 and 13.5. So then, if we added this up, how many people got between 41 and 25? Well, it's going to be 68 plus 68 plus, what's that, 27? 95% of the population will land between these two. And then 2.35 is the percent here of the population, and 2.35% here will land between 44 and 21. And anyone outside of 3 standard deviation points, in a normal standard deviation, normal distribution, only 0.15% of the population would be above that or below that. almost statistically insignificant. Okay, I would say, okay, how many people got above 45, above 44 on the test? Probably no one. Okay, probably no one, and probably no one got below 21. So that's how you kind of work with the normal distribution curve. Now, I would love you to write down these numbers under your chart if you can. And I'm going to erase this number. I'm going to put a number I like in there. Each, you notice these numbers up here are different. Ignore them. I want to keep it simple, so I'm going to use these numbers: 34, 13.5, 2.35, and 0.15. Okay, they're really simple numbers. Every time they're pretty much the same, but different rounding. So don't worry about these right now. Okay, so this first section is going to be 68%. Okay, the second section, all the way from -2 to 2, is going to be, what did I say, 95? Let's double check. 38 plus 13.5 plus 13.5, 95. Okay, that's my last number, 2.35. And the very last one is 99.7 as well. Okay, so write these numbers down. Now, all you do to get these numbers, you add these two together, adding these three together, and adding these four together. But you look at between -1 and 1 standard deviation point, so 1 standard deviation point on each side of the mean, 68% of the population will be there. 2 standard deviation points out, we're at 95. 3 standard deviation points out, we're at 99.7. So I might want to pause here to write down the numbers. I said a lot, so hopefully you follow along. And we're going to play with these numbers in a second. So we're back. So what questions could I ask with this? All right. So let's apply our knowledge a little bit. So a question I could ask that says, if the mean height in the school is 70 inches, with a standard deviation of 6 inches, what height range contains 68% of the population? What percent of the population is over 76 inches? I didn't finish the question. I will finish that in a second. So the first step you do is you fill out your numbers. Fill out your normal distribution chart with the numbers. So what do we know? Well, we know that the mean is 70. So 70 is going to go right in the middle. And our standard deviation is 6. So if I go to the right, I'm going to keep adding 6. So I can add 6 and get 76. Add 6 and get 82. And then I'm going to add 6 and I'm going to get 88. So plus 1, I add 1 times 6. Plus 2, I add 2 times 6. Plus 3, I add 3 times 6. Then as we go the other way, instead of adding, we are subtracting. So 64, 58, and 52. So mean goes in the middle. Then we add our standard deviation point as we go right. They're positive numbers, so I'm going to add. And on this side, I subtract my standard deviation. So I've got my chart filled out. First success. So let's answer the first question. What height range contains 68% of the population? So I need to look in here and find how I can make 68% of the population, the number 68. And if you look, boom, there's 2 34s, so 34 plus 34 equals 68. So I can go between 64 and 76 inches. So that being said, the population, so 68% of the students will be between those two heights. So what population is over 76 inches? So if we go back here, we'd look at our chart and we go to 76 and we're looking for what percentage is over. So we would, let me see if I can get the same green. Oops, where's my highlighter? So we're going to look at these numbers. So these are the percentages that are over 76 inches. So we can go back here and we're going to add all those up. So this would be 13.5, oops, 13.5 plus 2.35 plus 0.15. So 16% of the population is over 76 inches. Perfect. I forget what I was going to write here. So I might come back to that at the end when I remember what we wanted to do. Okay, so always fill out the normal distribution chart with your numbers, then use the fill out chart to solve the problem. All right, so let's look at the next one. All right, so we have notation this time. We're given a mean of 100 and a standard deviation of 10. Now, if I were to do this right now, let me just draw this real quick. If I was doing this on your paper, I would just draw something like this really badly. That's the mean. And I just sketched out 1, 2, 3. This would be -1. Yours will look better on your page, but just sketch something out just like this. These percentages are something you need to put to memory. Okay? You need to have these in your memory bank. I would just sketch this out and then apply the knowledge or the information they give you here. So pause the video here and see if you can fill out this normal distribution using the information given. Okay, so let's take a peek here. So I'm going to put my first one here. 100 goes in the middle because that's my mean. Now next one, I'm going to go up 1 standard deviation, so that's 110. Up again is 120. Up again is 130. And on this side, I'm going down. 90, 80, and 70. So I've got my chart made. Now, you can pause here if you want to try to answer these items. This one's a tough one. Okay. So what percent of population is contained between 100 and 120? So we're looking for between 100 and 120. So if we go to our chart and highlight from 100 to 120, we have this. Those two numbers. I can't go over because we're over 120. I can't go under because we're under there. So I would go back here. And this is going to be 34 plus 13.5, and I can't type 13.5, which equals 47.5% of the population are going to be between 100 and 120. Okay. Oops. This needs to go up here. There we go. Now, what two ranges contain 85.1% of the population? So here you have to figure out what 81.5. What numbers add to 81.5? Now, if I look and I go, what numbers add to 81.5? I'm looking at these three numbers add to 81.5, but also curiously, these three numbers add the 81.5. So I'd have two different ranges that could. I could go, if I look at my yellows, they could go from 80 to 110. Or if I look at my pinks, I could go from 90 through 120. Okay? That's a tough question. I like that. I like that for a test. So there's two stretches. There's two sections that could have 81.5% of the population. So here we go. Here's a different one. And feel free to pause and return, and I can answer questions tomorrow. Go back and rewatch the video. If 68% of the population of dogs has a weight between 55 and 65 pounds, now I just made up the thing dogs. I know some people have some little dog, such as Emma's dog, that won't weigh this much, but let's talk about real dogs. Have between 55 and 65 pounds. So that's the only information we know. But it gives us a key here of 68% with these two numbers as being the brackets. So if we know that 68%, we can go down here and look and say, what adds the 68? Well, these two add the 68. Correct? So that means my low one would go on this side, and my high one would go on this side. And knowing that every one of these intervals are the same, right? What number is halfway between 55 and 65? Well, it's 60. Then we can fill out our rest of our chart. That'd be 70. This is 75. This is 50. This is 45. Okay. So we filled out our normal distribution with our numbers 1, 2, 3, negative 1, negative 2, negative 3. So what is the mean of this? You're having to flip back. Well, the mean is the middle number, which is 60. Now here's a question here. What would you expect the heaviest dog to be? Well, if you were looking for the heaviest dog, what's pretty much your highest number here? I expect pretty much the heaviest dog would be around 75. Now, there are some dogs over it, 0.15, but if I were to make an educated guess, I'd be looking at 75. With knowledge that, yeah, there's going to be some over it, but that's pretty much the heaviest dog we're going to find. Let me look at the back of your homework questions, because I know there was one question I was going to ask. So let's practice. No, I think we're good. If I see it as I go through homework. So your homework's in your OneNote right now. First one says, tell me which ones resembles a normal curve. So a nice normal curve. It's not going to be perfect, but it should be something that has a hump in the middle and kind of symmetrical on both sides. Okay. These have 6, oh my God, I forgot these have 6 bins. So it's not going to be perfect. Okay, just be aware of that. Then for these ones here, use your knowledge, and for each one of them, draw out that curve. I can't express anymore how drawing out this and putting in these marks will make it a lot easier. And use your notes to self with the percentages in there. But draw this out, put your mean here. Oh, there's my mean symbol. Put your mean there and write the numbers in there, just like I did on the examples. Okay, what range you expect? We know those two things. I think we're good, right? I will take this up at the very beginning of class tomorrow, but I'm sure myself that I must have taught you everything. So go ahead, do your homework, and then the class video should show up here. It should be there right now for you. Okay, have a great day, and I'll see you tomorrow.